To do function composition, we're going to plug one entire function into another one. Think of substitution back when we did substitution and elimination to get an idea of what we're going to do. It's basically the same thing. And so let's go ahead and take a look at two different compositions. Let's start with the first one. We'd say f of g of x. And notice the g of x function is sort of nestled within the f function. If you know the Russian nesting dolls, those dolls where you can take it's split in half and there's a smaller one inside and split in half. It's kind of that idea. We have a function within another function. So connecting this back to substitution we did in the past, what I'm thinking is this is the g function, obviously because it starts with g of x. I'm going to plug that into the other function in place of x. If that's our connection back to substitution. So let me kind of show you how I'd start working one of these out. So I'm going to color coordinate this too. So for the outer function, it's the f function. So what I'm going to do is go ahead and write down the f function exactly the way it is, except where do you see that x, I'm going to put a big old blank parentheses. Everything else is identical though, the 4, the squared, everything like so. And that would be for any x you see. So if there's multiple x's, there'll be multiple blank parentheses. Well, as you can hopefully predict, what I'm going to do is in that blank space, since we're plugging in the g function, I'm going to write not x, but in this case 5x minus 2. So that gets written in place of x. So that's composition. I mean, that's basically what we're doing. Where these problems become a little bit annoying or tricky is the whole simplifying aspect. So while that is sort of like our initial answer, that's the composition, let me show you a few tricks that we can do to simplify these. All of these are old tricks from last semester, but let's take a look and see how this works. So first thing first, I have multiply by 4 and an exponent. Exponents come first in order of operations. However, I'm not allowed to distribute that 2 since there are 2 terms inside the parentheses. So what I'm going to do is write out what this actually means. 5x minus 2 squared means multiply it by itself. So I'm going to write it like so. At this point, we've used FOIL, we've used the box method. Many of you are able to do this in your head, which is great. I'm going to do it in my head if you want to see how to multiply that using the box method or something. I guess now's a great time to go watch an old video. So I'm going to get 25x squared minus, I'd have a 10x and another 10x, so minus 20x, and then plus 4. Again, I'm multiplying 5x minus 2 times 5x minus 2. And then my final step for simplifying is now going to be, let's distribute that 4. So I'm going to end up with 100x squared minus 80x. And then plus 16. Like in our last video, we did not get a single number as an answer. Instead, I get a brand new expression, a brand new function when I perform function composition. So let's go ahead and try a couple more examples. And again, the big tricky part with these can be the simplifying aspect. So our second problem, this is a little bit weird, but notice we have a function plugged into itself. So I can do composition where I plug something back into the original function. So let's start on the outside, the f function. I'm once again going to write the f function exactly as it appears, but in place of x, put a big old blank parentheses. And within that blank space, I'm going to write whatever function is inside of it. In this case, it's the same thing. I'm plugging something into itself. So within the parentheses, I'm going to write 4x squared, the function plugged into itself. Okay? So that's the actual composition. The simplifying is where it gets tricky, so let's talk about the simplifying. I'm going to kind of do what I did last time, where I'm going to just write 4x squared times itself. Although in this case, we could distribute the exponent. Since there's only one term, I could do that. That would be totally fine. But we'll get the same answer doing this method. So 4 times, if I multiply the parentheses together, 4 times 4 gets me 16. And then x squared times x squared gets me x to the 4th once I add those exponents together. And finally, multiplying the 4 and 16 gets me 64 x to the 4th power for my simplified function composition. I'm going to show you a few more examples. If you think you got it, great, you can go ahead and stop watching. Otherwise, I'll show you a few more examples. The next slide has a few that are, I think, extra tricky with the simplifying. Don't get hung up on the simplifying, though. Don't get stressed out about that. If you can get the initial composition done, that's kind of the big idea. The simplifying is just a bit of a review, I suppose, although not a bad review. So, again, if you think you got it, go ahead and stop watching and do something else. Otherwise, I'll show you a couple more examples of function composition. All right, so as promised, here are a few trickier examples, at least trickier as far as simplifying goes. Your initial step of plugging one function into another is really no different than we just took a look at. So let's take a look at 3 more examples. In this case, let's just start on the left, of course, and work our way across. So I want to plug the g function into the f function for the first example. So let's take the f function, write it exactly as it is, but in place of x, leave a big old blank space. So 2 times blank parentheses to the negative first power. And then within that blank space, I'm going to write the g function, which is 4x plus 1 in this case. All right, so kind of like last time, exponents have to come before multiplying by 2. And I cannot distribute the exponent if there's 2 terms in there. Last time we kind of wrote what was in parentheses times itself because we were raising it to the second power. I can't write this times itself -1 time. So really, here's the only thing I'm able to do. As we've done before with negative exponents, I want to change a negative exponent to something positive by moving it up or down in the fraction. And so in this case, the part that's being raised to the negative exponent is what's in parentheses. So that 4x plus 1 is going to be what gets sent to the bottom of the fraction. If you want to include it in parentheses, fine. Otherwise, that's good. The 2 does not have to move with that, and we don't want it to move. In fact, that stays in the numerator. I cannot cross out the 2 and the 4. We'll talk about that in a different unit, why we can't do it. So that represents my simplified composition. So in some ways, it's easier than the last one. It's less steps, but it's weird in what those steps are. So again, I'm just showing you some weird ones. So let's take the reverse of what we just did, g of f of x. So some people wonder if that will be the same thing, just if we switch the order. Let's take a look. This time, the g function is on the outside. So start with 4. Anywhere you see an x, put a big old blank parentheses, but everything else is identical. So 4 times something plus 1. What's getting plugged into that blank space this time is the f function. So let's get that in there, 2x to the negative first power. This time, the way the simplifying is going to work, once again, a very weird example, I can multiply the 4 and the 2 together. That exponent is within the parentheses, so I'm not breaking any order of operations. So I get 8x to the negative first power, and then plus 1. Those are not like terms, so I can't do anything with them. The only thing I can really do is, once again, work with that negative exponent. I want to move that down to the bottom of the fraction, and the 8 and the x are not attached. And so the 8 I don't want to move, but the x will get moved underneath of it. So 8 over x is the same as 8 times x to the negative first, and then that plus 1 is just a separate term, so that carries at the end. I cannot make that a 9. Those are not common denominators. I can't do anything with it. So again, in some ways it's easier, but because it's less work than what we took a look at, but it's weird examples. And finally, let's go ahead and do another composition where I plug something into itself. So the f function this time, so I'm going to do 2 times blank space to the negative first power. Where I saw an x, I put a blank space, and then within there, I'm going to plug the same function, so 2x to the negative first power. Okay, I said the other ones were definitely weird. Watch how weird this one is. So I'm okay to distribute my exponent. There's only one term. There's no plus or minus sign separating the pieces. So distributing that -1 is fine into the parentheses. So I get 2 to the negative first power, and then x to the first. My rule for a power to a power is to multiply. All right, so I don't like that negative exponent, so kind of like I did last time, I'm going to move that to the bottom. The x is fine, so I'm just going to move that 2 down underneath the x, kind of like I did with the 8 and the x. And so I get this, and there's one more thing I can do. Since I'm multiplying by 2 and then dividing by 2, well, those are just going to cancel each other out, and all that's left is just an x in this case. So kind of a lot of work just to end up with a single x as the answer, but that's my simplified answer. So that's composition, plugging one function into another. Don't get hung up on all the simplifying. I know that's where it gets tricky, but that's what it is. So just watch out with that simplifying.